Okay, so now taking a look at exercises 2 and 3, we're going to look at some data based on downloading some songs. So a broadband company timed how long it took to download 232 4-minute songs on a dial-up connection. So the dot plot below shows the results. So what can we observe about the download times from this dot plot? So we can see that it has almost a symmetrical pattern, okay, with almost that mound shape. Okay, so if we look at our range, we can see that the smallest time is a little less than 5. Okay. The largest time is over 17 minutes. And we see again it has that mound shape. So we see that we've got most of our time is between that 8 to 13 minute period. So now if we move on to letter B. So we think about, is it easy to tell whether or not 12.5 minutes is in the top quarter of the download time? So if I were to go to 12.5, is it easy for us to tell if it's in that upper quartile? Okay, not really, because we have 232 dots. So it's going to make it a little bit hard for us to determine exactly where that upper quartile is just by looking at it. Okay, so it's not easy. So what we have to do is go to our dot plot in order to have a better understanding of where each of these quartiles are located. So if we look at part C, the box plot of the data is shown below. So it's the same data, but now shown as a box plot. So let's take a look at answering those same questions, part A and part B. So what do we notice? Okay. So we see that about half of the times are above 10.6. 10.6 being right there. So now we have a little bit better understanding where our median is. And we can see, if we look at our box, we can see that our median is pretty close to the center of that box. So that gives us the impression that the distribution is roughly symmetric. Around the mean. So whereas before we saw that mound shape on our dot plot, now we see our box divided almost in half. So if we look at letter D, what are the advantages of using a box plot to summarize such a large data set? But then also, what are the disadvantages? So with lots of data, the dots in a dot plot overlap. And while you can see these general patterns, it's hard to really get anything quantifiable. The box plot shows at least an approximate value for each of the 5 number summary measures and gives us a pretty good idea of how the data are spread out. So the box plot gives us a better idea about variability, or how spread out the data is. But there are some disadvantages. Okay, so the disadvantage of this box plot is that the specific values in the data set are not given. Okay, so we don't see exactly what our dots are within each of these different quartile ranges. So that would be a disadvantage. So you lose some of that specificity of being able to see exactly each one of our dots. Okay? However, this is going to give us a little bit better summary. So if we move on to number 3 here, we have Molly. So she presented the box plots below to argue that using a dial-up connection would be better than using a broadband connection. So she argued that the dial-up connection seems to have less variability around the median, even though the overall range seems to be about the same for the download times using the broadband. Okay, so what would we say about that? So if we kind of zoom in here on our 2 box plots, okay, we see that the range is fairly similar. If we look at the broadband times, okay, again, we kind of have a little bit less variability. We have this nice spread around the mean, or the median. However, if we look over here at the broadband times, notice that our 2 whiskers have very different lengths, and that our box is shifted a little bit closer to the right side here. But again, the median's not directly in the middle. So we take a look at, over here, our median looks like it's at about 5, but that's in seconds. So we always want to pay attention to our units. So this 5 right here is actually in seconds. Okay, over here, we see again, our median is at about 10.6, so, but that's in minutes. So while this one might have less variability, the fact that you're measuring in minutes versus seconds is a pretty significant difference. So these have very different scales. So the time using broadband is centered near 5. Okay? 5 seconds, though, to download the song, while the median for dial-up is almost 11 minutes for a song. So this suggests that the broadband is going to be faster than dial-up, just on the fact that seconds are faster than minutes. So again, we want to make sure we're paying attention to the scale as well as those units. So now let's take a look at exercises 4 and 5. When we take a look at precipitation, and more specifically rainfall. So we're going to go back to our 2 cities, St. Louis and San Francisco. Okay? Remembering that St. Louis is more centrally located in the city versus San Francisco, which is out on the west coast. So if we're looking at our 2 dot plots, we see how many data points are in each dot plot, and what does each data point represent. Okay? Well, we've done this before. Okay? We should have 12 dots in each one because we're measuring the mean temperature across 12 months. So we're looking at the mean temperature across 12 months. So our next question here says, make a conjecture about which city has the most variability in the average monthly amount of precipitation, and how this would be reflected in the IQRs from the data of both cities. So if we just look at the placement of the dots, we see that in this case, St. Louis actually has less variability in terms of precipitation, okay, versus San Francisco, which has the most precipitation. I'm actually going to go up here and change this to precipitation. Okay, so We're no longer talking about temperature, we're actually talking about precipitation and rainfall. Okay? So what we could say by looking at this is San Francisco now has the most variability. Which would mean a higher IQR. Okay. So based on these two dot plots, okay, what are the approximate values of the interquartile ranges for the average monthly precipitations for each city? And then use the IQRs to then compare the two cities. So now what we're going to do is we're going to take a look at where the IQRs are. So again, we find the median. So 1, 2, 3, 4, 5, 6. So our median is going to be in here for St. Louis. Okay, 1, 2, 3, 4, 5, 6. So our median is going to be there for San Francisco. Okay, so then we find Q1 and Q3. Okay, so Q1, we can count 1, 2, 3 for Q1. Okay, remember we're going to take 6 divided by 2. That gets us 3. The same thing for St. Louis. So I have 1, 2, 3. So Q1 is in there between. Notice that Q1 for St. Louis is between 3 and 3.5. Okay. So then over here we look at Q3. 1, 2, 3. So for St. Louis, Q3 is going to be here. And then for San Francisco, we notice that the Q3 is going to be somewhere between these dots right here. So we're going to try to draw a line center of those 2 points right there, which looks like to be about 3.9. And we'll say that's Q3. Okay. So the IQR for St. Louis is about 4.2 minus 3.2 for an IQR of about 1. So we're going from 4.2 up here to about 3.2 right there. So then for San Francisco, we look at Q3 is about 3.9, and then Q1 is way over here at about 0.2, so we would subtract those. Okay, so that gives us an IQR of about 3.7. Okay. So that tells us, again, that San Francisco has a higher IQR. Which means there's more variability across the middle. Okay, right around that mean. So part D says, in an earlier lesson, the average monthly temperatures were rounded to the nearest degrees Fahrenheit. Would it make sense to round the amount of precipitation to the nearest inch? So if we look at our dot plot and imagine rounding all of those dots to the nearest inch. Okay. So all of these dots would round to 0. These would round to 1. Okay. So we have to think, would that make sense? Would that be helpful to us? Well, in this case, not really, because our range is not that far, going from 0 to 5. So if we start rounding to the nearest inch, we're going to lose some of the specificity, the accuracy of our data, because we're going to start moving them farther away from their actual measured amount. So in this case, it would actually be better to just keep them at their decimal places. So with a smaller range,